In this video, we are going to go through step-by-step method of finding the inverse of a 3 by 3 matrix. So we are given this A matrix, and the formula for finding the inverse of a matrix is the adjoint of the matrix over determinant of the matrix. So let us start by finding the determinant of the matrix. So I have determinant of A. In order to find the determinant, I need to use the element of the first row as my primary element, and I also need to switch the sign. So I will start with positive, then negative, then positive. So the first element is 0, so I have 0. Then all I need to do is to cancel the corresponding column and row of 0. So if I cancel the corresponding column and row, I will be left with this square matrix, which is -4, -2, 4, and 1. So I need to find the determinant of the matrix. So the next element is -3, but you can see the sign now is negative. So I have a switch of sign. So I have negative, then I have the element itself, -3. Then I find the corresponding square matrix. So I cancel the corresponding column and row of -3. So I will be left with 1, -2, then -3, and 1. So the final element in the row is -2, and the sign is positive. So I have plus, the element is -2. So I find the corresponding square matrix. So I do that by cancelling the corresponding column and row of -2. So I will be left with 1, -4, then -3, and then 4. So all I need is to simplify. So I have 0. So I find the determinant of this. So it will be -4 times 1, which is -4. Then I will have -4 times -2 is -8. Then negative, negative, I will have +3. Then I will have 1 times 1. I have 1 minus -3 times -2 is just 6. So I will have positive, negative, I will have -2. Then I will have 1 times 4 is 4. Then -3 times -4 is just 12. So I will be left with 0 into -4 plus 8. I will have 4. Then I will have +3. 1 minus 6 is -5. Then I will have -2. 4 minus 12, I will have -8. So I will be left with 0 times 4 is just 0. Then 3 times -5, -15. Then I will have plus 2 times 8, I will have 16. So it means my determinant is just -15 plus 16, which is just 1. So basically it means I have my determinant as 1. So this one will be my equation 1. So the second thing is to find the adjoint of A. So the first step of finding the adjoint of A is to find the minor of A. So minor of A is also a 3 by 3 matrix. And I need to consider each of the element of matrix A in order to find the minor of A. So I will do that going row by row. So I will start with element 0. So I need to cancel the corresponding column and row of 0. So I will be left with the square matrix -4, -2, 4, and 1. So I will just find the determinant. So it will just be -4 times 1, which is -4. Then -4 times -2, which is -8. So I will just have -4 plus 8, which is just 4. So it means I will have my 4 here. Then I will go to the next element. I will have -3. So I will cancel the corresponding column and row. So I will be left with 1, -2, -3, and 1. So that will just be 1, the determinant, then minus 3 times minus 2, so I will have 6. So I will have minus 5. So it means I will have minus 5 here. Then going to the third element for minus 2, cancel the corresponding column and row. So I will be left with 1, minus 4, minus 3, and 4. So I'll just have the determinant as 4, then minus 12, which is just minus 8. So I'll have minus 8. So going to the next element, which is the second row, I will have 1. I will cancel the corresponding column and row. So I will be left with minus 3, minus 2, then 4 and 1. So it will just be minus 3. Then I will have minus 8, which is just minus 3 plus 8, which is 5. So I'll have my 5 here. Then the second element, I will cancel the corresponding column and row. So I'll be left with 0, minus 2. Then I will have minus 3 and 1. So this is just 0 times 1, 0. Then minus 3 times minus 2 is just 6. So I will have minus 6. Then finally for 1, I will cancel the corresponding column and row. So I will be left with 0, minus 3, 1, and minus 4, which is just 0, minus 3, which is 3. So I will be left with 3. So now I have found my minor. So the next step is to find cofactor of A. So cofactor of A given by C is also a 3 by 3 matrix, and you can find it by using the appropriate sign from the minor of A. And what that means is we switch the signs in the rows and the columns. So I will start with positive, then I will have negative, positive. So here I have positive, so it means this one will be negative, then positive. Here is negative, so it will be positive, negative. Here I have positive, so it will be negative, positive. So now you can see 4 is positive already, so I will just have 4. Minus 5 is negative, so minus, I will have positive 5. Then minus 8 is positive, so I will just have minus 8. So here, going to the second row, I have plus 5, which is negative, so it will be minus 5. Then minus 6 is positive, so positive, negative is negative, so I will have minus 6. Then minus 9 is negative, so negative, negative will be positive, so I will have 9. Then the last row, minus 2 is positive, positive, negative is negative, so minus 2. Then this one is positive, but the sign is negative, so I will have minus 2. Then positive, positive is positive, so I will have 3. So the final step of finding the adjoint is taking the transpose of the cofactor matrix. So the adjoint is just the transpose of the cofactor matrix. So I will have my adjoint of A. So to find the adjoint of A, I just transpose my C matrix. So the columns will turn into row and the rows will turn into column. So starting with this column, I will turn it into row. So 4 minus 5 minus 2. Then this column will turn into my second row. So 5 minus 6 minus 2. Then the third column will turn into my third row. So minus 8, 9, and 3. So I have my 2. So looking at the formula for the inverse, you can see now I have my adjoint and I have my determinant. So all I need is to substitute, put 1 and 2 into my formula. So my A inverse will just be 1 over 1, then times my adjoint, which is this 4 minus 5. So basically it means my A inverse will be 1 over 1. So it's like I'm timesing 1 by the entire matrix, and I will just have 4 minus 5 minus 2, 9, and 3. So if you want to learn how to find the eigenvalues and eigenvectors of a matrix using Cramer's rule, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.